All right, today we are going to talk about factoring quadratics. But before we do that, we're going to review how to multiply. And these are multiplying binomials or trinomials. Essentially, in the first three examples, you'll see that it kind of looks like distribution. There's a number out front. And then there are several terms inside the parentheses. So the first example, there's one number out front, two terms in the parentheses. The second example, there are three terms in the parentheses. Third example, there are two terms. And so to multiply, all we're doing is distributing. So we're going to take this number in front of the parentheses and distribute it to the first term and then to the second. So when we multiply, we do 4 multiplied by x squared, and that gives us 4x squared. And then we do 4 times negative 2x, and that gives us negative 8x. And this is our final answer. So the final answer has no parentheses in it, and any like terms are combined. All right, let's do the next one. We are going to distribute the 4x to these three terms. So with this one, the term out front has a variable x. Okay, so we have to make sure that when we multiply, we think about two things. We multiply the coefficients first. So I'm going to do 4 times negative 3. That gives me negative 12. And then I multiply the variables. X times x squared is x to the third power. And that's because this x is essentially 1x. This is x squared, which means 2 copies of x. So in total, we have 3 copies of x. All right, I'm going to go to the next term. 4 times negative 5 is negative 20. X times x is x squared. And then lastly, 4 times negative 6 is negative 24. X, and this one has no x, so that's just 1x total. That's my final answer. All right, in our last example, we have 2x times 9x. So 2 times 9 is 18. X times x is x squared. 2 times negative 10, negative 20. 1x, copy of x, no x's, so that's just 1x. Final answer. Okay. So that's the first part, which should be a little bit of review from Algebra 1, I hope. Okay, our next section is on the greatest common factor. The greatest common factor hopefully is kind of self-explanatory. Greatest meaning the biggest. Common is things that they both have, so terms have in common. And factor is something, a like number or variable that divides evenly into another term, okay? So a factor is any number that divides evenly into a term. So the greatest common factor, or the GCF, is the greatest number or variable that divides evenly into 24 and 32. The biggest number possible that divides evenly into both of those terms. All right, so one way to think about this, and everyone will do this a little bit differently. Some of you will be better doing this in your head. Some of you might need to write down the factors. But I'm going to start with 24, the smaller number, and start thinking about factors. So numbers that divide into 24 are 1 and 24. That's the first two I thought of. So I'm looking for the greatest. So I'm going to look at the bigger number there, the 24, and ask myself if that divides into 32. And it doesn't. So neither of those are common factors. Then I'm going to go to the next number, 2, and see if 2 goes into 24, and it does. 2 and 12 go into 24. So I'm looking for the greatest common factor, so I'm going to check 12. Does 12 divide into 32? And it doesn't. All right, so I'm going to check 3. 3 and 8 go into 24. So I'm going to check the bigger of the two, 8. And 8 does divide into 32, which means that the greatest common factor is 8. Okay, let's check our next one, 5, 10, and 45. So again, we're looking for the greatest number that divides into these numbers. So if I'm looking for the GCF of 5, 10, and 45, the biggest it could possibly be is essentially like the smallest number. So that's the one I'm going to start with. So I'm going to start with 5 and list off some factors. The only factors I can think of for 5 are 1 and 5. It's a prime number. It doesn't have very many factors. So I check those two numbers. I'm looking for the biggest, so I'm going to check 5. Does 5 divide into 10? Yes. Does 5 divide into 45? Yes. So the greatest common factor is 5. Okay, let's check 28 and 48. I'm going to start with 28 because it can't be any bigger than 28. And I'll start listing factors. So 1 and 28. And I'm going to check if 28 goes into 48, and it doesn't. Then I'll check my next factor. 2 and 14 go into 28. I would check if 14 goes into 48, and it doesn't. Okay, 3, and actually 3 doesn't go into 28, so I'm going to skip 3. 4 and 7. Okay, does 7 go into 48? No. 4 does go into 48, so I'm going to keep 4 in mind, and I'm going to go on to think of other factors, and the next number would be 5. 5 does not go into 48, or 28, sorry. 6 does not go into 28, and the next number would be 7, and I already know that 7 does, and this matches 4. So I'm going to say that the GCF is 4. Okay, our next section is going to build on the GCF. And this is how we factor out a GCF. So essentially factoring out a GCF is kind of like doing distribution in reverse. We can think of it as undistributing. So distribution, this is an example like we did in the very beginning, is when we have a number outside the parentheses, we multiply that number to the terms inside the parentheses, and we get our final answer. Now, if you look at factoring, it's doing that exactly in reverse. Look how my end result is actually what I start with here. And that means ultimately what I want to end with was that original problem. So the 5 outside the parentheses and the 2x plus 7 inside. So our answer just looks different. It's like we flip the answer and the what we started with. So let's look at some examples. So we're going to break these down. So if the directions ever tell you to factor out a GCF, what you do is you look at how many terms you have. So in this first one, I have 2 terms. The first thing is I think about what the GCF is. And so again, this might be more difficult for some of you than others. Take your time. Think about what divides evenly into both of these numbers. And I know that my GCF is the number 6. 6 is the biggest number that divides into 12 and 18x. All right, so what I'm going to do is set up what my answer is going to look like. My greatest common factor, 6, is going to be in front of a set of parentheses. And I always actually know how many terms should be in my parentheses. Since I started with 2 terms, I should have 2 terms in my parentheses here. And what I have to do is figure out what number do I have to put here that would get me 18x. So you have to work backwards a little bit. 6 times what would give you 18? Well, that has to be 3. And then I need 18x, and my 6 doesn't have an x, so I have to make sure I have an x there as well. Okay, my second term is positive 12. So right away, since I see it's positive, I'm going to put a plus sign here. because my 6 is also positive, so I know I need a positive. And I'm just thinking, what do I put here? What do I multiply 6 by to get 12? And that would be 2. And so this is my final answer. All right, let's look at an example that has 1, 2, 3 terms. Okay, so first let's think of our greatest common factor. The smallest of these numbers is that number 10. So I'm going to start there and think of factors of 10. I like to start with 1 and 10. And I can see that 10 divides evenly into 10, into 40, and into 20, which means 10 is my greatest common factor. Okay, so my GCF, or my greatest common factor, is 10. I'm going to put 10 outside a set of parentheses. And then in the parentheses, since I have 1, 2, 3 terms, I know I'm going to have 1, 2, 3 terms. So what I'm thinking about now is what goes here and here and here that would multiply to get these 3 terms. So back to my original. Okay, so first, what goes in the first spot? That would get me 10x squared. So I notice that it's the same number, 10 and 10, which means I don't really need to multiply it by anything. You could write 1, but you don't really need to, right? I don't really need a number there. So I'm going to just ignore that, and I'm going to move on to my x squared. So this term has an x squared, this one doesn't, which means I need an x squared in that first spot. 10 times x squared is 10x squared. Okay. Now our next one in this spot is what multiplies by 10 to get 40x. Okay, so 10 times what number gives me 40? Well, that's 4. And I need an x because that's 40x. And it's positive, so I'll put a plus sign. All right, lastly, what do I multiply by 10 to get positive 20? That's a positive 2. Okay, so my final answer is right here with the 10 out front and then these 3 terms inside. Okay, our last example, our greatest common factor between 48, 24, and 42 is 6. So I'm going to put our greatest common factor as 6. And if we write this in factor form, I would put a 6 out front. I need space for 3 terms. And I have to think about what do I put here that would take me from 6 to 48x squared. And that would be an 8 because 6 times 8 is 48, and I need an x squared. Okay, next I need to multiply something by 6. That would get me negative 24x, so I need a negative. And 6 times 4 is 24, and then an x. And then lastly, positive 42, I need a plus 7. Okay, let's move on to the next page of your packet, which is right here, and this is on how to factor quadratics. So we're moving on to factoring a little bit more complicated expressions. So before we do this, we are also going to review how to multiply when it's a little bit more complicated than just distributing. And there's a method that some of you guys may have learned in Algebra 1 that makes multiplying something like this a little bit easier. So when I look at these expressions, I have 2 sets of parentheses, right? The first set has 2 terms. The second set has 2 terms. So what I'm going to do is set up a box, you might remember this, with 2 sets of parentheses. The first set I'm going to put, it actually doesn't matter if you put it along the left side or the right side, but 2x minus 4. And then along top I'm going to put x and 8. And then what you're doing inside the box is just filling in what happens when you multiply an x times a 2x. So x times 2x is 2x squared. All right, now I'm going to do 8 times 2x. So 8 times 2 is 16, and then an x. Then x times negative 4 is negative 4x. And lastly, 8 times negative 4 is negative 32. If you use the box method, the nice thing is that your like terms are always set up for you. So on this diagonal are always going to be terms that have a variable in common, which means you can combine them. So when we write our final answer, we have to combine our like terms. So our answer should be that first box, 2x squared. Then I'm going to combine my like terms, so positive 16x minus 4x is positive 12x. And then that last box, negative 32. And this is my final answer. So very often when we multiply binomials, we end up with a trinomial, which is an expression that has 3 terms. Okay, let's try the next one. I'm going to set up my box, 2 by 2, 3x and a minus 5, and a 2x and a minus 6. 3 times 2 is 6, x times x is x squared. 3 times negative 6 is negative 18, and I have an x. Negative 5 times 2 is negative 10 with an x. And then lastly, careful here because I have 2 negatives, negative 5 and negative 6 is positive 30. Look on the diagonal, we have like terms. So when I write my final answer, I put the answer from the first box, 6x squared. I combine my like terms, negative 18 and negative 10 is negative 28x. And then my last term is a plus 30. Okay, for this last one, I actually want you to cross off this y. I don't want to deal with that y out front. I want you to just practice. And I'm going to set this up, but I want you to try this one on your own. So here's x minus 4 and 3x plus 6. So I'd pause the video and try that one on your own. So here's the final answer for that one. Hopefully you paused and tried that one on your own to see if you